Titan may not be alive, and that is exactly why it matters. A living world is noisy. It eats its own evidence. It turns chemistry into bodies, bodies into fossils, fossils into rock, and rock back into the slow furnace of a planet that never stops changing. A living world does not preserve its beginning gently. It buries it, burns it, dissolves it, feeds on it, and builds over it with forests, oceans, microbes, bones, storms, oxygen, and memory. That is why Earth is such a difficult witness. We stand on the only world known to have life, and the closer we look for the moment life began, the more the planet seems to have hidden its own origin. The oldest rocks are rare. The ancient atmosphere is gone. The early oceans are gone. The chemistry that came before cells has been folded into a planet transformed by cells. Earth succeeded so completely that it erased the clean scene of the crime. So we look outward. Not because another world must repeat Earth. Not because every orange sky or buried ocean is a promise of creatures waiting in the dark. The universe does not owe us another version of ourselves. We look outward because other worlds preserve conditions Earth no longer can. Some of them are dead deserts. Some are frozen shells, some are volcanic nightmares. And one of them, far from the sun, wrapped in orange haze, moving around Saturn like a hidden planet. Maybe one of the most important places in the solar system for understanding what came before biology. Titan is strange because it is almost familiar. From space it does not look like the moon. It does not look like the broken stone of an airless satellite. It looks sealed, covered, protected. Its surface hides beneath a thick amber atmosphere, a world behind a curtain. The sunlight that reaches it has traveled nearly 1 billion miles, arriving pale and weak, then scattering through layers of hydrocarbon haze, until day itself becomes a dim orange glow. For a long time, Titan was not a landscape to us. It was a rumor. Astronomers knew it was large, they knew it had an atmosphere. They knew something was happening there that did not fit the old idea of a moon as a dead companion. But the surface was hidden. Titan kept its face turned away, not by rotation, but by weather, chemistry, and smog. It did not shine with the clear icy brightness of other moons. It looked like a secret. Then spacecraft began to strip away the mystery without destroying it. Radar saw through the haze. Instruments sensed the atmosphere. A probe dropped through the orange sky and landed on the surface. And what appeared was not a fantasy world, not a living jungle under Saturn, not a frozen version of Earth. It was something more unsettling. It was a world with river channels, a world with dunes, a world with clouds, a world with rain, a world with lakes and seas gathered near its poles like dark mirrors. A world with shorelines, a world where the surface seemed to have been carved, transported, sorted, and weathered. The shock was not that Titan looked alien. The shock was that Titan looked partly understandable. Human eyes are trained by Earth. We know what flowing liquid does to ground. We know the branching shape of drainage. We know the way dunes form under wind. We know that clouds mean cycles, that rain means exchange, that shorelines mean a boundary between air, land, and liquid. Titan offers those shapes, those gestures, those familiar verbs. Then every noun changes. The lakes are not water, the rain is not water. The rivers are not water, the rocks may be ice frozen so hard that it behaves like stone. The sand may be dark organic grains made by chemistry in the sky. The air is mostly nitrogen, thick and cold, with methane woven through it. The seas are not blue. They are black hydrocarbon basins, filled with methane, ethane, and other compounds under an orange sky. The weather is real, but it is not our weather. The landscape has an Earth-like grammar written in an alien language. That is the tension that makes Titan unforgettable. It is like Earth just long enough to pull us close. Then it becomes something else. On Earth, rain is part of the water cycle. The sun lifts water from ocean and soil, vapor rises, clouds gather, rain falls, rivers flow, lakes fill, ice forms, oceans breathe with the atmosphere. Life grows inside that cycle so deeply that we sometimes forget the cycle existed before us. Water is not only scenery here. It is blood for the planet. On Titan, methane plays a role that feels eerily similar from a distance. Methane can evaporate, form clouds, fall as rain, flow across the surface, carve channels, collect in lakes, and return to the air. Ethane joins it in the cold reservoirs. The Moon has something like hydrology. But the liquid is not the liquid that fills our cells. Titan is not a wet world in the human sense. It is a world where natural gas rains from the sky. That sentence should sound impossible, but on Titan it is ordinary climate. The cold is so extreme that substances we treat as gases on Earth become liquids. Methane does what water cannot do there, because water is locked into ice. Under Titan's surface conditions, water is not a flowing sea or falling rain. It is part of the ground, it is bedrock. So Titan reverses the imagination. The familiar thing becomes alien, and the alien thing becomes normal. A river can run through a valley, but it is a methane river. A shoreline can curve around a lake, but the lake is a dark hydrocarbon sea. A cloud can form above a landscape, but the rain that falls from it would freeze the story of life, as we know it, rather than feed it. And yet, Titan is not chemically barren. That is the real reason it matters. High above the surface, sunlight and energetic particles strike methane and nitrogen in the atmosphere. Molecules break apart, fragments collide, carbon, hydrogen, nitrogen, and other ingredients recombine into more complex forms. The orange haze is not just fog. It is chemistry made visible. It is the atmosphere manufacturing organic material and letting it drift downward, grain by grain, molecule by molecule, across geologic time. Organic does not mean alive. That is one of the hardest ideas to keep clear, because the word itself seems to lean toward biology. On Earth, organic matter makes us think of bodies, soil decay, food forests, oil, blood, leaves. But in chemistry, organic means carbon-based. Carbon chemistry can exist without a cell ever appearing. It can be made in atmospheres, in interstellar clouds, on comets, in meteorites, on icy surfaces, in laboratory flasks, and on worlds that may never grow so much as a microbe. Titan forces that distinction into view. It is rich in organic chemistry. That is not the same as being rich in life. A world can have ingredients and still not have a recipe that completes itself. It can have molecules and still not have metabolism. It can have carbon and energy and liquid movement and time, yet never produce a system that copies itself, adapts, and evolves. Titan may be one of the best places we can reach to study the difference. The difference is everything, because life did not appear on Earth from nothing. Before the cell, there had to be chemistry. Before biology, there had to be molecules with the right structures, environments that concentrated them, energy sources that drove reactions, boundaries that separated inside from outside, and pathways that allowed complexity to persist, instead of dissolving back into chaos. Somewhere in that deep past, non-living chemistry crossed a threshold. It became organized enough to remember. It became capable of inheritance. It began to make imperfect copies, and those imperfections became the raw material of evolution. No one has recovered that moment. No fossil records the instant chemistry became biology. No rock gives us a clean photograph of the earliest self-replicating system. No ancient ocean remains bottled beneath the crust for us to open. The origin of life is not hidden because scientists lack imagination. It is hidden because time is violent. Earth has had billions of years to erase the beginning. Titan may preserve a kind of before, not Earth's before exactly. That matters. Titan is not early Earth placed in a freezer. It is colder, darker, farther from the sun, built around different surface liquids, different energy conditions, and different chemistry. The comparison must be handled with care. A bad comparison turns Titan into a cartoon. A careful comparison makes it more powerful. Titan is valuable not because it repeats Earth, but because it separates things Earth mixed together. It gives us a world with a thick nitrogen atmosphere, but no oxygen-rich biosphere. A world with weather, but no water rain on the surface. A world with organic molecules but no confirmed life. A world with liquid shaping land but not the liquid that fills Earth's oceans. A world where prebiotic chemistry can be studied without being swallowed immediately by biology. That is why Titan can feel like a memory of early Earth, even while being profoundly not Earth. It does not show us our planet's infancy in literal form. It shows us a question from that infancy. What can chemistry build before life arrives? Imagine descending through Titan's atmosphere. At the top, the moon is a golden sphere, smooth and unreadable. Saturn hangs nearby, immense and quiet, its rings wide enough to feel like architecture. As you fall closer, the haze thickens. Sunlight turns copper. Distance becomes soft. The atmosphere is deeper than expected, more like a place than a boundary. The sky is not empty black. It is layered, it is physical, it has color, weight, and weather. A probe falling through it would not pass instantly from space to ground. It would drift through a chemical world. The air would grow denser, winds would shift, haze particles would surround the descent. Somewhere below, hidden at first, the surface would begin to take shape as dark and pale regions, channels, plains, and the suggestion of landforms carved by forces no human has ever touched. Then, near the ground, the moon becomes intimate, not welcoming, not survivable, but intimate. The Huygens probe, which landed on Titan in 2005, revealed a surface that looked almost painfully real. The images were not sharp by modern cinematic standards, but that gave them a stranger force. They showed an orange-brown landscape, a horizon, rounded icy objects, and drainage-like features seen during descent. It looked not like a painting of alien grandeur, but like a place where weather had happened before the camera arrived. That is what made it haunting. A fantasy world announces itself too loudly. Titan did the opposite. It looked quiet, worn, dim, patient, as if it had been waiting under its haze for billions of years, not for us, but for chemistry to keep happening. The human mind wants company. It sees lakes and asks what swims there. It sees organic chemistry and asks what crawls or breathes. It sees a hidden ocean and imagines ecosystems. That instinct is understandable, but Titan punishes impatience. Its gift is subtler than a creature in a lake. Titan teaches that a world can be active without being alive. The wind can sculpt dunes without footsteps ever crossing them. Rain can fall without roots taking it in. Rivers can carve ground without fish, algae, reeds, insects, or mud filled with microbes. Organic haze can settle for ages without becoming soil in the biological sense. A lake can reflect the sky and still not be a habitat for anything we know. This is not emptiness. It is the stage before the actors. And sometimes the stage is what scientists need to understand. On Earth, almost every environment with liquid water and usable energy has been invaded by life. Boiling springs, acidic pools, deep crustal fractures, hydrothermal vents, polar ice, desert rocks, clouds, ocean sediments. Life is persistent, opportunistic, and chemically aggressive. It changes the conditions it occupies, it eats gradients, it transforms minerals, it alters gases, it spreads signatures everywhere. That makes Earth magnificent. It also makes Earth messy. If a scientist wants to know what organic chemistry does without biology, Earth is a contaminated laboratory. There are still ways to study prebiotic chemistry here, of course. Laboratories can simulate environments. Rocks can preserve ancient clues. Meteorites carry compounds from beyond Earth, but the planet itself is not clean. It has been biologically edited for billions of years. Titan may be one of nature's unedited drafts. A draft does not have to become the final story to be valuable. Sometimes the draft reveals the choices that were made, the paths that were possible, the structures that almost formed, the limits that stopped them. Titan is a draft written in cold. Its surface temperature sits far below anything comfortable to Earth life. The cold slows reactions. It hardens water. It changes what counts as a liquid, what counts as rock, what can evaporate, what can flow. That cold is not a small detail. It shapes everything. It may make some kinds of chemistry too slow to matter at the surface. It may preserve molecules that would react away quickly elsewhere. It may allow organic materials to accumulate like a chemical archive. Cold is not only absence. Cold is storage. On Titan, the atmosphere keeps making complex organic material, and the surface keeps receiving it. Some of it may gather in dunes. Some may be transported by wind. Some may fall into lakes and seas. Some may be buried. Some may be altered by occasional impact heating or by contact with water ice. Over immense stretches of time, a moon can build a chemical landscape without ever building life. That phrase, chemical landscape, is important. Titan's chemistry is not confined to a beaker. It has geography, it has weather, it has seasons, it has reservoirs, it has movement from air to ground, and perhaps from surface to interior. It is not a single reaction but a planetary system. On Earth, we often imagine the origin of life beginning in one special place: a warm pond, a deep vent, a tidal flat, a mineral surface, a wet-dry cycle, a volcanic island, a pore in rock. Each hypothesis has reasons behind it, and the debate remains alive because the evidence is incomplete. Titan does not settle that debate. But it expands the imagination by showing that organic complexity can be planetary before it is biological. A whole world can participate in prebiotic chemistry. That does not mean a whole world becomes alive. It means the boundary between geology, atmosphere, and chemistry is richer than old categories allowed. Titan sits in that boundary. The dunes may be made of particles formed from atmospheric organics. The lakes may dissolve or concentrate certain compounds. The methane cycle may move material between surface and sky. Impact craters may create temporary warm environments where water ice melts and mixes with organics. A subsurface ocean may exist beneath the crust, perhaps with water and dissolved materials, though hidden from the visible landscape. Each setting offers a different chemical possibility. Dragonfly was designed for this kind of world. A rover would be limited by terrain. A stationary lander would be limited by one place. Titan offers a rare advantage: thick air and low gravity. Flight there is not easy, but it is easier than on Mars in a crucial sense. The atmosphere can support a rotorcraft. A machine can land, study, lift off, cross the landscape, and land again, turning a distant moon into a sequence of scientific encounters. That is why the Dragonfly mission feels almost mythic, even before it arrives. A flying laboratory sent to an orange moon of Saturn, a rotorcraft crossing dunes made of organic material, a machine listening to the chemistry of a world before life. It sounds invented, but the real mission is more disciplined than the fantasy. Dragonfly is not being sent to chase monsters. It is not being sent because life has been found. It is being sent to investigate habitability, surface composition, geology, atmospheric conditions, and how far prebiotic chemistry may have progressed. Its power lies in restraint. The most honest question is not whether Titan will hand us life. The question is what Titan will teach us if it does not. That may be the harder lesson for the public imagination. Space stories often want a climax: discovery, signal, fossil, organism, ocean, announcement. But science often advances through landscapes of almost habitable, almost familiar, almost like Earth, almost the right chemistry, almost enough. Titan may be the world of almost. And almost is not failure, almost is the region where understanding grows. If Dragonfly finds complex organic materials shaped by atmosphere and surface processes, that matters. If it finds evidence that organics interacted with liquid water in past impact environments, that matters. If it finds chemical pathways that produce molecules of astrobiological interest without biology, that matters. If it finds no biological signature at all, that also matters, because it helps define how far non-living worlds can go. The absence of life can be a measurement. A silent world can still speak. Titan's silence, if it remains silent, would not be the silence of a stone. It would be the silence of a laboratory, where the experiment never crossed the threshold. It would tell us that organic richness alone is not enough. Weather alone is not enough. A thick atmosphere alone is not enough. Liquids alone are not enough. Time alone may not be enough. Something about environment, energy, solvent, cycling, concentration, temperature, or continuity may decide whether chemistry becomes Darwinian or remains chemical. That is why Titan is not merely a moon, it is a test of our assumptions. From of modern's astrobiology, water has been the great guide. Follow the water. The phrase became powerful because every known form of life depends on water. Liquid water is an extraordinary solvent. It allows reactions, transport, structure, and flexibility. It is central to Earth biology so completely that ignoring it would be foolish, but Titan complicates the phrase without replacing it. At the surface, Titan follows methane. Below the surface, it may hide water. In the atmosphere, it follows organic photochemistry. Across the whole moon, it asks whether habitability is a single condition or a layered story. The surface lakes of methane and ethane are not water oceans. No one should casually call them seas of life. Their chemistry is different. Their temperatures are brutal for familiar biology. Reactions that support Earth life would not simply transfer there. Yet the existence of stable surface liquids outside Earth is astonishing by itself. Titan is the only world beyond Earth known to have persistent liquids on its surface in the form of lakes and seas. Even if those liquids are not water, that fact does not make Titan alive. It makes Titan geologically and chemically dramatic. The lakes are not just scenery. They are participants in the moon's climate. They store methane and ethane. They interact with the atmosphere. They may change with seasons. They may have shorelines shaped by evaporation, precipitation, infiltration, or waves. They may concentrate certain compounds and exclude others. They may be smooth, dark, and radar reflective in ways that make them stand out against the icy land. Imagine those lakes under Titan's sky. Not blue, not sparkling with sunlight, not warm, not restless in the way Earth's oceans are restless. They might look like black glass, or oil, or a mirror made of cold chemistry. The horizon would be close because Titan is smaller than Earth. The light would be weak. The atmosphere would tint everything amber. A shoreline might curve into darkness. Above, Saturn might be hidden by haze, but its gravity would be present in the moon's orbit, in the larger architecture of the system, in the simple fact that this world belongs to a giant planet. A human standing there would die without protection. But imagination can stand there briefly. It would hear, it would smell nothing through a sealed suit. It would see a landscape that appears calm, but is chemically alive in the non-biological sense. A landscape where molecules are being made, moved, frozen, dissolved, and stored. A landscape that resembles Earth enough to ache, then denies every earthly comfort. This is the emotional core of Titan. It is beautiful because it does not care about us. It is instructive because it refuses our categories. We want worlds to be dead or alive, barren or inhabited, Earth-like or alien. Titan sits between those words and makes them feel crude. It is active but not known to be alive, familiar but not Earth-like in the way that matters for comfort. Organic rich but not biological. Wet with liquids but dry of water at the surface. Cold but chemically creative. Distant but connected to the origin story of our own planet. That complexity is why a good Titan documentary cannot be a list of facts. The facts are only the bones. The real story is the tension inside them. A moon has weather, but the weather is methane. A moon has rivers, but the rivers run through ice. A moon has organic chemistry, but organic chemistry is not life. A moon may help explain life's origin, but not by being alive. The mind keeps reaching for Earth and coming back with something else. That rhythm is the heartbeat of Titan. When we think about early Earth, we often imagine a violent young planet. Impacts, volcanoes, steam, black oceans, lightning, chemical soups, hydrothermal systems, unstable atmospheres. Energy everywhere. Some of those images are supported in broad form. Many details remain debated. The early planet was not a single scene. It changed over time. It had environments, not one environment. It had local conditions that may have come and gone. It had water, rock, gases, heat, and chemistry under a young sun. Titan is not that. Titan is cold where early Earth was warm. Titan's surface liquids are hydrocarbons where Earth's were water. Titan's energy budget is weaker. Titan's chemistry proceeds under different constraints. Yet Titan may preserve one feeling that belongs to the prebiotic Earth. The feeling of a world before biology has reorganized everything. No grass. No algae. No oxygen-rich sky. No soil made by ecosystems. No animals disturbing sediments. No roots breaking rock. No microbes coating surfaces. No biosphere turning every chemical gradient into an opportunity. Just planet, atmosphere, liquid, energy, and organic chemistry. That is the echo, not a copy. An echoes are distorted. They arrive changed by distance. But they can still tell us something about the original sound. Titan's echo comes from a moon where sunlight is weak, but time is abundant. The atmospheric haze is built slowly. The methane cycle turns slowly. Seasons unfold over long stretches. The entire world has a rhythm unlike Earth's, quick weather and living surfaces. If Earth is a roaring orchestra of biology, Titan is a low note held for ages. That low note matters because beginnings may be slow. The origin of life was not a magic spark in the cartoon sense. It was likely a long set of chemical transitions, with many failures, side paths, unstable intermediates, environmental changes, and selection-like processes before true biology. Molecules had to persist long enough to matter. Systems had to be protected enough to continue, but open enough to exchange energy and material. There had to be cycle, concentration, variation, and continuity. Titan may reveal what happens when some of those ingredients are present, but others may be missing or limited. It may show organic abundance without warmth. It may show surface liquids without water. It may show chemical complexity without metabolism. It may show atmospheric production without biological consumption. It may show a world where prebiotic chemistry is not a straight road to life, but a landscape of possibilities and dead ends. Dead ends are not useless. In science, dead ends tell us the shape of the maze. One of the most important things Titan can teach is humility. The search for life is haunted by projection. We want to find ourselves. We see water and imagine fish. We see carbon and imagine cells. We see a planet in the habitable zone, and imagine continents under clouds. We see a signal and imagine intelligence. The desire is not foolish, it is human, but nature is not required to satisfy human narrative. Titan is a warning against lazy hope. It says, here are lakes, but not your lakes. Here is rain, but not your rain. Here are organics, but not your organisms. Here is a world before life, perhaps, or without life. Certainly as far as evidence now shows. Will you still care? A mature science culture must answer yes. We must care about worlds that do not flatter us. We must care about chemistry that does not become biology, about planets that fail to ignite, about moons that hold clues without giving us headlines. The universe is not only valuable where it resembles a home. It is valuable where it reveals how rare, difficult, or contingent home may be. Titan may deepen the mystery of life by not containing it. That possibility gives the world its gravity as a story. When Dragonfly eventually flies, it will not move through a neutral backdrop. Every meter will carry a question. The rotorcraft may sample dunes, where organic particles have accumulated. It may analyze materials that fell from the atmosphere. It may investigate regions influenced by impact processes, where water, ice, and organic compounds could have mixed under temporary warmth. It may measure conditions that reveal how Titan's chemistry is organized from place to place. A single landing site could not do that. Flight matters because Titan is varied. Aerial mobility turns distance into method. It allows comparison. It lets scientists ask whether one region differs chemically from another, whether dunes and interdunes tell different stories. Whether surface materials record atmospheric processing, whether impact environments altered the chemical inventory. Dragonfly is not merely going to Titan. It is going to move through Titan. That motion has symbolic force. For the earliest human observers, Titan was a point of light near Saturn. For telescopes, it became a disk. For spacecraft, it became a hidden world. For Cassini and Huygens, it became a mapped and touched landscape. For Dragonfly, it may become traversable. Exploration turns abstraction into geography. Geography changes thought. Once a world has places, it can have comparisons. Once it has comparisons, it can have history. Once it has history, it becomes harder to reduce it to a single phrase. Titan is not just the methane moon. It is a system of poles and dunes, lakes and plains, atmosphere and interior, seasons and reservoirs, ancient deposits and active cycles. That richness is what makes it scientifically dangerous in the best sense. It can surprise us. Good worlds surprise us. Mars surprised us by being more watery in the past than its present desert face suggests. Europa surprised us by making an ice-covered ocean world seem plausible. Enceladus surprised us with plumes from a small icy moon. Venus, in its terrible way, surprises us by showing how Earth-size does not mean Earth-like. Titan surprised us by giving a moon climate, organic chemistry, and seas under a sky. The solar system keeps punishing simple categories. Titan may punish the simplest category of all. That life is the only interesting outcome of chemistry, life is the most dramatic outcome. From our point of view, it leads to evolution, ecosystems, consciousness, technology, and questions like this one. But before life, chemistry had its own drama. Molecules formed and broke, energy moved, environments changed. Some structures persisted longer than others, some reactions created products that influenced later reactions. Complexity did not need a cell to begin accumulating. Titan lets us watch a non-living world where complexity still has a story. This is why the orange haze is so important. It is not just atmospheric decoration. It is evidence that Titan's upper atmosphere is a reactor. Methane and nitrogen are transformed into a suite of compounds, some of which contribute to aerosols. These particles settle downward, linking sky and ground. In a sense, Titan's surface is being fed by its atmosphere. Not with life-giving rain in the Earth sense, but with carbon-rich material produced by sunlight-driven chemistry. The sky writes onto the land. On Earth, the sky also writes onto the land through rain, snow, dust, ash, oxygen, carbon dioxide, nitrogen compounds, and the products of life. But Titan's writing is different. It is darker, colder, less biological. It may build dunes from organic grains. It may coat ice. It may provide feedstock for reactions in rare environments, where liquid water appears temporarily. It may accumulate in ways that become chemically interesting over enormous timescales. This slow descent of organics has a poetic quality, but it is not only poetry. It is a mechanism. Mechanisms are where wonder becomes science. Wonder without mechanism becomes fantasy. Mechanism without wonder becomes a manual. Titan requires both. A strong documentary voice must let viewers feel the orange sky and understand that its beauty comes from photochemistry. It must let them see the black lakes and understand why methane and ethane can remain liquid there. It must let them imagine Dragonfly flying and understand that Titan's dense atmosphere and low gravity make rotorcraft exploration plausible. It must let them feel the prebiotic mystery and understand that no confirmed life exists there. The more carefully we draw the boundary, the more powerful the story becomes. Claims weaken Titan. They make it smaller than it is. Saying Titan has life, without evidence reduces a profound world to cheap speculation. Saying Titan could teach us what chemistry does before life is more difficult, but it is far richer. It allows the moon to remain itself. It respects the silence. Silence is part of planetary science. Most worlds do not speak in signals, speak in surface chemistry, crater count, atmospheric spectra, isotopes, gravity fields, radar echoes, temperature profiles, and landscapes. Titan's voice is not a voice at all. It is a pattern of evidence that must be interpreted with patience. Patience is hard in the age of instant headlines. A mission launches, and the public wants life. A telescope sees a molecule, and the public wants proof. A planet sits in the habitable zone, and the public wants oceans. But nature tends to answer with gradients, not announcements. More likely, less likely, consistent with, not yet known, possible under certain conditions, requires more data. Titan lives in those phrases. That is not a weakness. It is where real science happens. Consider the methane itself. Methane in Titan's atmosphere should be broken down over time by sunlight. The fact that methane remains present raises questions about how it is replenished. The answer is still not fully settled. There may be reservoirs, interior processes, or exchanges between surface and atmosphere. The methane cycle is active, but its long-term maintenance remains part of the mystery. That mystery is not decorative. It affects how we understand Titan's history. Has Titan always had its current methane-rich climate? Has methane appeared in episodes? Are the lakes stable across long timescales, or part of changing reservoirs? How does methane move into and out of the surface? How do seasons reshape the distribution of clouds and liquids? Titan's climate is not a static painting. It is a system with questions. Now place organic chemistry inside that system. If methane is part of the atmospheric chemistry that makes haze, and haze produces organics that settle onto the surface, then the methane cycle is not only climate. It is a supply chain for prebiotic material. The weather does not merely shape land. It participates in chemistry. The Moon's climate and its astrobiological relevance are interwoven. On Earth, climate and life are also interwoven, but through biology. Plants, microbes, oceans, rocks, and atmosphere exchange gases and energy. Titan lets us consider climate and organic chemistry without known biology. That comparison may help scientists separate what a planet can do by physics and chemistry alone from what life adds when it appears. That distinction matters far beyond Titan. Astronomers searching exoplanets will find atmospheres. They will detect gases, temperatures, perhaps clouds, maybe surface conditions indirectly. Interpreting those signs will require knowing what non-living worlds can produce. A false positive for life is always possible if abiotic chemistry mimics a biosignature. Titan is a reminder that organic complexity is not automatically biological. The universe can make suggestive things without making organisms. In that sense, Titan is training. It teaches us how not to be fooled. It also teaches us how not to be disappointed too easily. A world can fail to host life and still be central to astrobiology. A world can be uninhabited and still hold clues to origins. A world can be hostile and still be chemically meaningful. Habitability is not a simple stamp placed on a planet. It is a set of conditions, histories, materials, energy flows, and timescales. Titan may be habitable in some limited or past or subsurface contexts. It may be prebiotically rich at the surface. It may be chemically fascinating without being biologically active. Those possibilities are not the same, and keeping them separate is part of respecting the science. The surface is where the drama becomes visible. Titan's equatorial dunes stretch across vast regions, dark bands shaped by wind. On Earth, dunes are often made of silicate sand. On Titan, the grains may be organic-rich particles, perhaps formed from atmospheric material that settled and was processed into mobile sediments. The idea of hydrocarbon dunes under orange skies sounds like a dream, but it is a sober planetary interpretation. Dunes mean wind, wind means atmosphere, atmosphere means exchange. Exting means surface materials are not simply lying still forever. They are being transported, sorted, buried, exposed. A grain on Titan may have begun as chemistry high in the sky, fallen through haze, joined a surface deposit, been moved by wind, perhaps encountered methane rain, perhaps been buried in a dune field. That is a life story for a molecule without life. The word story is not too strong if used carefully. science often reconstructs histories without characters. A rock has a story. An atmosphere has a story. A molecule has a story if we can trace its formation, movement, transformation and loss. Titan is full of such non-living stories. The lakes tell another one. Near the pole, radar dark regions revealed bodies of liquid. Some are small lakes, some are seas. Their distribution is not random. Titan's polar geography, seasonal cycles, topography, and methane reservoirs all matter. The seas create a scene that seems almost biblical in its strangeness. Liquid under an alien sky, coastlines on a moon, a hydrological system made from hydrocarbons. Yet the lakes are not where Dragonfly is currently planned to land. That may surprise viewers who imagine the mission diving straight toward the most dramatic scenery. But science does not always begin with the most cinematic place. Dragonfly's planned exploration focuses on regions where it can study organic-rich materials, surface composition, and sites that may have experienced interactions between organics and water ice. Including areas associated with impact processes, this is more interesting than simply visiting a lake. A lake shows the methane cycle directly. But an impact environment may reveal something rare. A place where Titan's organic material and liquid water could have interacted temporarily. On Titan, water is normally frozen hard at the surface. But impacts can melt ice. For a limited time, they can create warmer environments where chemistry changes. If complex organics meet liquid water, even briefly, new pathways may open. That does not mean life appears. It means chemistry gets a chance to move through conditions more relevant to origin questions. Chance matters. The origin of life may not require a planet to be uniformly friendly. It may require temporary environments, repeated cycles, local concentrations, interfaces, and changing conditions. A world can be mostly hostile and still contain moments or places where chemistry becomes interesting. Titan's impact sites may be such places, not because they are magical, but because they bring together ingredients and conditions that are usually separated. Separation is one of Titan's great themes. The surface has organics but is cold. The interior may have water but is hidden. The atmosphere makes molecules but does not make cells. The lakes provide liquid but not the solvent Earth life uses. The moon has pieces of the puzzle, but not obviously the arrangement that produces biology. Dragonfly's journey is, in part, a search through those separations. What has mixed, what has remained apart, what has been altered, what has been preserved? The answers may be subtle. They may not make dramatic headlines. But in origin of life science, subtle answers can matter enormously. A molecule detected in a particular context may constrain a pathway. A surface composition may reveal processing. A comparison between sites may show how Titan's organic inventory changes across landscapes. Measurements of atmosphere and ground can link the global cycle to local chemistry. This is why a 30-second news headline cannot hold Titan. The moon requires slow attention. It requires looking at the Black Lake and not immediately filling it with creatures. It requires hearing organic and not translating it into alive. It requires letting a world remain unresolved. That kind of patience is not dull. It is suspense of a deeper kind. There is a cinematic suspense in Titan's stillness. A spacecraft approaches a moon whose face is hidden. A probe falls through orange haze. A camera reveals channels cut by alien rain. A radar map shows dark seas near the poles. A future rotorcraft waits in clean rooms on Earth, designed for a sky no human will breathe. The viewer knows something is coming, but not what answer the world will give. That is better than a fake answer. Real suspense lives in uncertainty. The title people might give Titan in their minds is, "The world before life." But that phrase must be understood as metaphor and scientific possibility, not a claim that Titan is literally Earth's past. It is before life in the sense that it may show chemistry before biology, or chemistry without biology, or chemistry that approaches some ingredients of origin without completing the transition. It is a world that lets us imagine a prebiotic stage in a form we can explore. It is also before life emotionally. It feels like a planet before green, before oxygen, before voices, before hunger, before the landscape became scenery for organisms. A river on Earth is almost never only a river. It is habitat, resource, border, migration route, food chain, symbol. A river on Titan may be only physics and chemistry, liquid moving downhill through frozen terrain, carrying dissolved and suspended materials, changing the shape of the land. There is purity in that, but not innocence. Titan is not gentle. Its cold is absolute from a human perspective. Its beauty is indifferent. It has no need to become alive in order to be complete. That is another lesson. Human beings often treat life as the purpose of planets. But planets and moons existed long before life, and most may exist without it. Chemistry does not fail because it remains chemistry. A world does not fail because it remains uninhabited. The universe is not an audition for biology, yet biology did happen here. That fact makes Titan's non-living chemistry more meaningful, not less. We know that somewhere, under some conditions, chemistry can cross over. We are proof. The question is not whether the transition is possible. The question is how often, how easily, under what conditions, and through what pathways. Titan gives us a nearby natural laboratory for exploring the prelude from a different angle. The word laboratory can make Titan sound sterile. It is not sterile in appearance. It is vast, atmospheric, and dramatic, but scientifically, it does what a laboratory does. It isolates variables. It lets us examine processes that Earth obscures. It gives us a system where organic chemistry, atmosphere, liquid hydrocarbons, ice, and potential subsurface water can be studied together. The laboratory is the size of a world, and the experiment has been running for ages. Ages matter because chemistry is not only about ingredients, it is about time. Reactions may be slow, accumulations may take millions of years, surfaces may preserve old materials, climate cycles may repeat, impacts may punctuate the quiet with brief warmth. Titan's clock is not the human clock, it is a planetary clock, slow enough that even a frozen world can change. What does methane rain sound like on Titan? No microphone has carried that full scene to us from a storm at a shoreline, so we must be cautious. But the imagination can work from physics. Drops falling through thick air in low gravity, liquid striking icy ground, channels briefly darkening, a world where rain is not nourishing but sculpting. No smell of wet soil, no insects rising, no green response. Just hydrocarbon weather rewriting a frozen surface. On Earth, rain often means relief. On Titan, rain means chemistry moving. This difference is essential. Every Earth analogy must break. A Titan lake resembles a lake only in geometry. A Titan river resembles a river only in motion. A Titan cloud resembles a cloud only in behavior. A Titan dune resembles a dune only in form. The materials tell a different story. The more precise we become, the more alien Titan feels, and the more alien it feels, the more useful the comparison becomes. Because early Earth is not easy to imagine without smuggling modern Earth into it. We picture oceans, but we picture blue oceans under familiar skies. We picture coastlines, but we picture land that will someday grow plants. We picture chemistry, but we picture it in a world already haunted by life. Titan helps break that habit. It gives us a landscape with familiar shapes, stripped of familiar biology. It lets us feel prebiotic strangeness, not accurately in every detail, but emotionally and scientifically enough to matter. There is another kind of humility Titan demands. Humility about solvents. Earth life often uses water so deeply that water feels synonymous with possibility, but chemistry is broader than life as we know it. Scientists can ask whether other liquids might support forms of organization under different conditions. Methane and ethane are very different solvents from water. They are nonpolar, cold, and limited in ways that make Earth-like biochemistry extremely difficult. That does not justify fantasy life claims. It just means Titan is a place where questions about alternative chemistry can be framed carefully. Carefully is the word. A careless story says, methane lakes, therefore life. A serious story says, methane lakes create stable surface liquids and unusual chemical environments, but any life there would require chemistry unlike terrestrial biology, and no such life has been found. A careless story says, organic molecules, therefore biology. A serious story says, organic molecules are necessary ingredients in known life, but can form abiotically, and Titan is valuable because it lets us study that abiotic complexity. A careless story says, early Earth twin. A serious story says, Titan is not early Earth, but it may illuminate prebiotic processes, and the difference between chemical richness and biological emergence. The serious version is not less exciting. It is more exciting because it is true. Truth gives wonder a place to stand. When viewers see Dragonfly rise over Titan in an animation, they are not watching science fiction. They are watching a mission concept built around known physical conditions: dense atmosphere, low gravity, a surface accessible to a rotorcraft, and scientific goals rooted in chemistry and habitability. That does not make the mission easy. Titan is far away, the environment is cold, communication is delayed, autonomy matters. Every part must survive launch, cruise, entry, descent, landing, and operations on another world. The romance of Dragonfly comes partly from its difficulty. A machine born on Earth must learn to fly where no wing has ever carried life. It must become an insect in a world without insects. The name is perfect for that reason, but also dangerous if taken too literally. Titan has no dragonflies. The machine's name evokes movement, delicacy, and aerial exploration, but the moon itself remains biologically silent. The poetry belongs to the mission, not to an ecosystem. That distinction does not weaken the image. It sharpens it. Dragonfly will be a living world's question sent into a non-living sky. It will carry the curiosity of biology into a place that may show biology's prehistory. Human technology is made by life. Every spacecraft is a product of cells, evolution, intelligence, metallurgy, language and society. When a rotorcraft lands on Titan, life will have reached the moon in one sense, not as native biology, but as an emissary from Earth. A living planet will touch a prebiotic world with instruments. There is something almost ceremonial about that. Earth, the world that forgot its beginning, sends a machine to a world that may have preserved a different kind of beginning. The machine does not ask questions in words. It samples, measures, heats, analyzes images, transmits. It turns landscape into data. Then, across the distance from Saturn to Earth, scientists reconstruct meaning from signals. That process is slow, but it is how the unknown becomes less vague. No single measurement will explain life. That is not how origins research works. But measurements can narrow possibilities. They can show what molecules are present, how they are distributed, what environments preserve them, how surface materials vary, whether certain compounds appear in contexts expected from atmospheric chemistry or from further processing, and whether past water-organic interactions left detectable traces. A world before life will not explain itself in one sentence. It will reveal itself through patterns. Parts require patience. That patience should shape the narration. Instead of racing from fact to fact, the story should linger where the mind catches. A black lake under orange haze, a river that is not water, a sky manufacturing organics, a rotorcraft crossing a silent dune field, a hidden ocean beneath ice, an impact crater where frozen water may once have melted. The strange possibility that a lifeless moon can teach us about life. Each image deepens the same question. What happens before biology? Not before life in calendar time alone, but before life as a principle. Before a molecule becomes part of a cell. Before chemistry acquires memory. Before the environment contains organisms that alter every cycle. Before evolution begins choosing among variations. Before death exists, because death requires life. Before hunger exists, because hunger requires systems that maintain themselves. Before purpose appears, even the blind chemical purpose of metabolism, Titan may be full of processes, but empty of purpose. That is not bleak, it is clarifying. Purpose is something life adds to matter. Before life, reactions happen without hunger, without fear, without reproduction, without survival. Molecules do not want to become cells. Chemistry does not aim at biology. But under some conditions, systems emerge that persist, copy, and vary. Then selection can act. Then purpose-like behavior begins, not from intention, but from survival. Titan sits in the imagination before that turn, a world where chemistry may be elaborate, but not yet Darwinian. This matters because many discussions of life in the universe skip the hardest step. They ask how many planets are habitable, how many have water, how many orbit in the right zone, how many have atmospheres. Those questions matter. But the origin of life asks whether chemistry actually crosses the threshold once conditions are favorable. We do not yet know whether that step is easy or rare. Earth offers us an example. One example is both everything and almost nothing. It proves the transition can happen. It does not reveal how common it is. It does not tell us whether life appears quickly whenever conditions allow, or whether Earth was lucky in ways we do not yet understand. To answer that, we need other cases, or at least other natural laboratories showing the chemistry around the threshold. Titan may not give us a living case, it may give us a near-threshold case, or a far-from-threshold case, or a case where organic chemistry becomes complex under conditions too cold or too chemically constrained to proceed toward biology. Any of those outcomes would help. This is what makes Titan so scientifically mature as a target. It is not a simple yes or no gamble. It is a world where almost any careful answer improves our understanding. If prebiotic chemistry is rich, we learn. If it is limited by cold, we learn. If surface organics are heavily processed, we learn. If impact sites show water organic chemistry, we learn. If the methane cycle is more complex than expected, we learn. If the moon is chemically active but biologically silent, we learn. The public often imagines space missions as treasure hunts. Titan is more like entering an archive whose language we are still learning to read. The archive is written in haze, ice, hydrocarbons, dunes and time. Archives can be quiet, they do not shout when opened. The value lies in interpretation. That is why Titan's beauty should be portrayed not as decoration but as evidence. The orange color tells of atmospheric particles, the black lakes tell of stable surface liquids under extreme cold, the dunes tell of wind and sediment transport, the channels tell of flowing liquid, the haze tells of chemistry, the possible hidden ocean tells of layered habitability. The future flight of Dragonfly tells of a world whose physical conditions make a new kind of exploration possible. Every image should carry information. Every fact should carry mood. A viewer should feel the world before they are asked to understand it. Then understanding should make the feeling stranger, not smaller. Start with the lake, a dark shoreline under orange light, no waves visible from far away, or perhaps faint ripples under slow wind. The liquid is not water, and that single fact turns beauty into unease. On Earth, a shoreline invites life, even when a coast looks empty. The mind fills it with microbes, shells, fish, birds, algae, footprints, salt, smell. Titan shoreline gives the shape without the biology. It is a coast without a biosphere. Then move to the sky. The haze is not weather in the simple sense. It is a planet-scale chemical veil. It hides the ground and creates the colors that make Titan iconic. It also links the upper atmosphere to the surface. Sunlight too weak to warm Titan like Earth can still break molecules and begin chains of reactions. Energy does not have to be abundant to matter, it has to be usable over time. Then move to the dunes. They are not desert in the Earth sense, because desert on Earth is defined against water and life. Titan's dunes are part of a hydrocarbon world, shaped by wind and perhaps made from organic-rich grains. They suggest a surface where atmospheric chemistry becomes sediment, where carbon compounds are not just floating in the air but forming landforms, then move to Dragonfly. Not as a heroic machine alone, but as the thread connecting human curiosity to Titan's chemistry. It will not arrive as a conqueror. It will arrive as a listener. Its instruments will ask what the ground is made of, how chemistry varies, what environments may preserve or alter organics, and whether the ingredients and conditions on Titan tell a deeper story about life's chemical origins. Then return to Earth. Because every Titan story is secretly an Earth story, not because Titan is Earth, but because Earth's beginning is missing. We do not know exactly how non-life became life here. We know life emerged early in Earth's history, but the path remains debated. We know organic molecules can form in many settings. We know water, energy, minerals, cycles, and concentration mechanisms matter. We know modern life uses DNA, RNA, proteins, membranes, metabolism, and complex cellular machinery, but those cannot simply appear fully formed. There had to be predecessors, simpler systems, transitional chemistry. Titan does not contain the answer like a sealed envelope. It contains analogies, contrasts, and experiments. The contrast may be its greatest strength. A world with abundant organics but deep cold asks whether temperature is a gate. A world with methane liquids asks whether water's role is unique or merely one possible pathway among many, though the only one known to work. A world with a subsurface, ocean, asks whether habitability can be hidden from the landscape. A world with temporary water from impacts asks whether brief windows can matter. A world with no confirmed life asks whether prebiotic chemistry often stalls. These are not small questions. They reach into the deepest uncertainty in astrobiology. How inevitable is life? The word inevitable is dangerous. It suggests destiny, and science is not destiny. Still, the question haunts every discussion of origins. Given the right chemistry and enough time, does life tend to appear? Or did Earth pass through a narrow gate? Are the ingredients common, but the transition rare? Are there countless Titan-like worlds where organic chemistry accumulates beautifully and never wakes? Titan may not answer alone, but it gives us a place to begin testing the edges. There is a sadness in imagining a world where chemistry never becomes life. But it is a human sadness. Titan does not experience failure. It does not wait for biology with disappointment. Its methane rain falls whether or not anyone calls it meaningful. Its lakes darken the poles, whether or not they contain anything living. Its atmosphere makes haze because physics and chemistry allow it. The universe does not need witnesses, yet witnesses exist. That changes the story for us, because life did arise somewhere, and that life now asks why. We are not outside the origin question. We are its consequence. Every attempt to understand prebiotic chemistry is matter trying to reconstruct how matter became curious. Titan becomes a mirror, but not a mirror that shows our face. It shows the background before faces. It shows a world where the machinery of landscape operates without biology. It shows carbon chemistry without cells. It shows weather without a biosphere. It shows the kind of planetary activity that might precede or accompany the conditions from which life could someday emerge. This is why Titan's non-living nature, if confirmed, would be valuable rather than disappointing. A lifeless Titan rich in organic chemistry is a boundary marker. It tells us that complexity can go this far and still not cross. It helps define what life is not. That is as important as defining what life is. Definitions sharpen through contrast. We understand flame partly by knowing heat without flame. We understand thought partly by knowing computation without consciousness. We understand life partly by studying chemistry without life. Titan may be chemistry without life on a planetary scale. That phrase carries more power than any invented creature. A creature would make Titan another habitat. Chemistry without life makes Titan a missing chapter in the universal story. The chapter is not simple. The moon may have changed over time. Its methane may not have been stable in the same way forever. Its climate may have shifted. Its surface may preserve evidence of past processes we do not yet understand. The distribution of lakes, dunes, plains, and possible cryovolcanic or impact-modified terrains may tell a complex history. The subsurface ocean, if present, may have its own chemistry isolated from the world above. Titan is not a museum exhibit frozen into one condition. It is an active system under cold constraints. The word active needs care. It does not mean alive. It means processes continue. Atmospheric photochemistry, methane weather, sediment transport, possible surface-atmosphere exchange, internal dynamics perhaps less visible. Activity is not biology, but biology is one form of activity built on chemistry. Studying non-biological activity helps us understand the foundation. That foundation is easy to overlook because life is so visually dominant on Earth. Remove life from Earth in the imagination, and the planet becomes almost unrecognizable. No forests, no coral reefs, no grasslands, no soils as we know them, no oxygen-rich atmosphere maintained by photosynthesis, no animals stirring sediments, no human lights at night. The Earth before life was not simply Earth with empty scenery. It was a different planet. Titan reminds us that planets without life are not blank. They have weather, chemistry, geology, and beauty. A lifeless world can be full of events. This matters for how we teach science. Too often, non-living worlds are presented as stages waiting for life, as if their only value is whether biology appears. Titan resists that. Its prebiotic relevance is tied precisely to its non-living status, but its worldliness is also independent. It has a climate, a surface, a history. It deserves attention not as a failed Earth but as Titan. That respect allows better storytelling. The Moon is not almost Earth in a simplistic way. It is Titan, a large moon of Saturn, with a dense nitrogen atmosphere, methane weather, hydrocarbon lakes, organic haze, icy terrain, and a set of chemical questions no Earth landscape can pose cleanly. Its value comes from its difference. Difference is not a barrier to understanding, it is the path. When Cassini mapped Titan, it revealed a world too complex for old assumptions. When Huygens landed, it gave human beings a view from the ground of a moon, in the outer solar system. When Dragonfly flies, it may turn Titan into the most intimate extraterrestrial landscape ever explored beyond Mars. Each mission changes the scale of the question. From haze, to surface, to movement, the next step is not only technological, it is conceptual. We must learn to think of Titan not as a place that either has life or does not matter, but as a world that matters because it may show the chemistry life emerges from, or fails to emerge from. There is a phrase often used in origin research: chemical evolution. It can mean the gradual increase in molecular complexity and organization before biological evolution begins. Titan is a place where chemical evolution can be investigated in an environment not dominated by known life. But the phrase must not be mistaken for biological evolution. Molecules can become more complex without becoming organisms. Systems can change without becoming alive. That distinction should run under the entire narration like a hidden current. The Moon is not dead in the sense of inactive. It is not alive in the sense of biology. It belongs to the in-between category our language handles poorly: prebiotic, abiotic but organic rich, chemically active. Potentially informative. None of those words carry the emotional force of alive, but they may be more important for understanding how alive ever became possible. Language struggles, because human culture is built around living experience. We know birth, growth, hunger, sickness, death. We know landscapes by what lives in them. A forest without animals still feels alive, because the trees breathe. An ocean without visible creatures still feels alive, because we know microbes fill it. Titan denies that intuition. It gives us landscape without ecology. A valley on Titan is not lonely because loneliness requires a mind. But we feel loneliness when we imagine it. That feeling can be useful if it leads to humility rather than projection. The emptiness we sense is our own biology noticing its absence. Titan becomes a negative image of Earth, a photograph where life has been removed, and chemistry makes. What remains is not nothing. What remains is the beginning of the question. In the oldest story of Earth, there must have been a time when rain fell into a world, with no organism to receive it. Waves moved without plankton. Rocks weathered without lichens. Hydrothermal fluids rose without ecosystems built around them. Organic molecules formed, arrived, or accumulated without being consumed as food. Energy gradients existed before metabolism captured them. That Earth is gone. Titan is not that Earth, but it helps us feel the strangeness of such a world. Feeling matters because origin of life science can become abstract quickly. RNA, amino acids, membranes, hydrothermal gradients, UV photochemistry, mineral catalysis, lipid vesicles, polymerization, autocatalytic networks. These ideas are powerful, but for many viewers they float without scenery. Titan gives scenery to the idea of prebiology. Even if the chemistry differs from Earth's, it gives an orange sky to the question, it gives black lakes to the question, it gives wind-shaped dunes to the question, it gives a flying mission to the question. That is why the topic can hold a long documentary. It is not one fact repeated. It is a world that keeps deepening the same paradox. The more Titan resembles Earth, the less Earth-like it becomes. The more organic it is, the more careful we must be not to call it alive. The more useful it is for origin of life research, the more important its non-living nature may be. This paradox can carry the viewer from opening to ending if every sequence returns to it in a new form. A viewer begins with wonder, a moon with lakes, then unease. The lakes are methane, then curiosity. Methane participates in weather, then mystery. The atmosphere makes complex organics, then caution. Organics are not organisms. Prebiotic chemistry may be planetary. Then mission. Dragonfly will fly through this world to measure it, then reflection. Titan may show us what Earth can no longer show, not life but the before. No labels are needed. The progression can be felt through images and turns. The opening should place the viewer on the edge of recognition. A world that looks almost like a planet from a dream of Earth. Then remove comfort piece by piece. The rain becomes methane, the sea becomes hydrocarbon, the rock becomes ice, the sky becomes chemical haze, the organic material becomes non-living carbon chemistry. The mission becomes not a hunt for animals but a search for conditions and pathways. This removal is the drama, not adding aliens, taking Earth away. The result is stranger. Titan is a lesson in subtraction. Take Earth Rome, warmth, Rome surface water, Rome oxygen breath, Rome biology, leave nitrogen air, carbon chemistry, weather, liquid landscapes, time, and a hidden ocean far below. What remains is not Earth. What remains is Titan, a world that seems to ask whether the universe makes many beginnings and only some continuations. That question can haunt the ending. After all the science, the viewer should be left not with a neat conclusion but with a deeper sense of the boundary. Life is not just another feature like a crater or a cloud. It is a planetary revolution. When it appears, it changes everything. Titan may show us a world where the revolution has not happened, and by seeing that, we may better understand how extraordinary the revolution was here. There is a danger of turning this into human exceptionalism. That should be avoided. The point is not that Earth is special in a sentimental sense, or that life is impossible elsewhere. The point is that we do not yet know how common the transition is. Titan keeps the question open. It neither confirms abundance nor proves rarity. It gives us evidence to gather. The best ending should stand in that openness. A black lake, orange haze, dragonfly's shadow crossing frozen ground. No answer yet. Only a world where the prelude is visible. The moon continues without waiting for us. Saturn rises and sets behind haze. Seasons crawl. Methane evaporates, condenses, falls, flows. Organic particles descend from the sky. Dunes move slowly. Lakes hold their dark surfaces. Beneath the crust, water may remain hidden. separated from the cold surface by layers of ice. Above, the sun is a distant lamp, and somewhere on Earth, engineers build a machine to fly there. This connection between worlds is one of the most moving parts of the story. The origin of life on Earth eventually produced a species that could wonder about the origin of life. That species built instruments, learned chemistry, mapped planets, crossed interplanetary space, and chose to send a rotorcraft to a moon, where no life has been found, because the absence itself may hold a clue. That is not just exploration, it is a loop in cosmic history. Chemistry became life here, life became intelligence here. Intelligence now returns to chemistry elsewhere to ask how the loop began. Titan is waiting at the other end of that question, not waiting consciously, not waiting for us in any literal sense, but waiting as all unexplored worlds wait, with conditions already present, evidence already written, answers already embedded in matter. Long before any observer arrives, the human drama is late. Titan has been Titan for ages. That timescale should humble the narration. The moon is not new because we found it. Its lakes did not become meaningful when radar saw them. Its atmosphere was making haze before human language existed. Its methane cycle moved through seasons before any eye on Earth knew Saturn had moons. Its chemistry has been running under the same distant sun that warmed the early Earth in a far stronger light. We arrive not as creators of meaning but as late readers. The page is old, the ink is orange haze, black liquid, icy crust, and organic dust. The question written there is simple only on the surface. How close can a world come to the ingredients of life without becoming alive? The answer may change how we see not only Titan, but Earth, because after Titan, Earth looks less obvious. Water no longer seems merely common, it becomes transformative. Oxygen no longer seems like background air, it becomes a biological monument. Soil no longer seems like dirt, it becomes a living product. A river no longer seems just a river, it becomes part of a biosphere. Even decay becomes remarkable, because decay is life feeding on life. Titan strips those things away so we can see them again. That is what alien worlds do at their best. They return us to Earth with new eyes. Mars makes water precious, Venus makes climate fragile, Europa makes oceans mysterious, Titan makes life's beginning feel strange. Not because Titan explains it completely, but because Titan shows us a world where the stage exists without the play we know. It shows weather without biology, organics without organisms, lakes without water, and a future mission that may test the chemistry of the threshold. A viewer who reaches the end should that Titan is not a side curiosity of the solar system. It is central to one of the oldest questions human beings can ask in scientific form: why is there life rather than only chemistry? The question sounds philosophical, but Titan makes it physical. It gives it a place. A moon, an atmosphere, a lake, a dune, a rotorcraft, a sample, a spectrum, a molecule. That is the power of planetary science. It takes questions that once belonged only to myth and places instruments beside them. Origins were once stories told around fire. Now they are also measurements made by machines in orange haze. The mythic feeling remains, but it is disciplined by data. Titan deserves that kind of telling. Mythic in atmosphere, strict in truth. No animals in the methane sea, no secret civilization under the haze. No false announcement of life. Only a world more interesting than those inventions because it is real. A world where black lakes lie under a sky made orange by chemistry. A world where rain falls and nothing known drinks. A world where carbon compounds gather without becoming forests. A world where Dragonfly will one day rise into alien air and ask what the ground remembers. A world before life, perhaps not in time, but in meaning. A world that matters because it may show us the prelude without the chorus. Titan may not be alive, but it may help explain why anything is.